Hello, I am Greta Carrete, and I am a scientist at Vizzuality. And with me today is Luisa.
Hi, I'm Luisa Teixeira, and I'm a project manager at Vizzuality.
So today we are very happy that we are here at this conference organized by Carto. And what we would like to talk about is how data science and GIS communities are in relation to climate related projects. So as we mentioned earlier, we work at Vizzuality, where we have developed some products that bring together these two communities. Luisa?
So actually, when we received this invitation from Carto, we thought it would be really nice to reach out internally to the rest of the team and discuss a little bit what our ideas and our thoughts are on this topic, because we do have a very varied team. So it's really nice to gather the perspectives. And we convened a bunch of colleagues. We reflected about some of the projects that we've been working on that bring together the GIS, the data science communities, and touch climate change. Some examples are Climate Watch, Forest Forward, and the Global Forest Watch. And I think that we will be trying to tell you a little bit about the summary of what we came together and discussed. And to start with, I guess it would be nice if we would introduce ourselves and explain a little bit what's our background and how we relate to data science and GIS individually. So Greta, maybe you could start.
Yes, so my background is, for now, mostly academic. Since starting my career, I then did my master's and my PhD, and then I joined Vizzuality a year and a half ago.
So in my case, before I joined Vizzuality, where I'm working as a project manager, I actually worked with GIS in making ecosystem maps. So I did some coral reef mapping in Mozambique, and I've done some advisory in terms of which technologies to use for different kind of conservation projects.
So somehow already it was here, you and I, it's not completely clear to which community we belong, but yeah. I guess I am more data science than you are, and you are more GIS than I am. So we are kind of the non-voted representatives of these communities, right?
Yeah, I'm definitely not data science, so I am GIS in this conversation.
So in our experience at Vizzuality, you and I, Luisa, we are working together, and it's not only PMs, project managers, and scientists. There's even more communities working together. There's scientists, designers, engineer, and what we were talking about is who belongs to each community, right? So and that was tricky.
Yeah, I actually think that in the end we realized it's more like a spectrum maybe, and depending on, and also like we said before, this is like a tool set. So depending on what you want to do, you may have to go more in the direction of one or the other. And I think one of the reasons we realize this is happening, and particularly for us that focus a lot on environmental topics and problems, is that these problems are transcendental. So we actually need to bring together different communities and different fields of work to find solutions, because there's not just one solution. There's not just one perspective, and trying to work towards this inclusivity that's both technically, scientifically, and socially what we're trying to do really brings out this need of overlap. And the GIS and the data science are really going hand in hand, both because of scale, but also even just technology available.
Yeah, and also the other part that we were talking about was so the data science, the GIS communities, we can talk among us, but then whatever that is stuck there has to leave and go somewhere else. And in that sense, having engineers and designers that have such as well diverse background from archaeology to marketing, which maybe it's more usual, but then we have people also that studied medicine, or they were going on a rock band on tour for many years. It's also to have an angle that is more of open, and it what it allows to be working with so many different types of points of view is that a problem is seen from a different angle, and the solution that someone sees is not the solution that works for someone else, and we are kind of building on top of each other's knowledge to try to come up with a better solution.
Yeah, and I mean, this is something that we're really, I guess, I'm not going to say we focused on, because it's very inherent to our conversations. It just comes up naturally. And it's really cool that we're challenging each other's biases and kind of in the process deconstructing them a bit. Because if I come from an environmental field, I'm kind of really, in engineering, I have a very specific approach that someone that comes from sociology doesn't have. And this complementarity is really interesting, and how we like shed light into each other's, I would say, like maybe blind spots or dark areas. So it's not really fun, to be honest. And one of the things that we actually talked about was how this is very fitting to the problems we're dealing with, in this notion of, if we think about wicked problems versus tame problems, this is something that really kind of makes sense. But maybe you want to tell us a bit about what wicked problems are?
So it's climate change is sometimes considered as a wicked problem. So it means that depending from the way you define it is different from another person, and climate change is changing. Climate change is changing continuously, but not just the climate is changing, but the way we talk about it, the way science around it is going on. So there is this concept of wicked problems, which are like an ongoing thing that cannot be made static, and then the tame problems, which are the ones that we are most used to like observe, hypothesize, and then try to find a solution and apply it. So having a dynamic system like climate change is, and having a dynamic ongoing conversation like we do at Vizzuality with this problem, it's helping us to be more aware of each other's, to be more aware of each other's background, each other's biases, as you were mentioning. So what we found is that we need to keep on having ongoing conversations, and this conference is one of those spaces, right, to just talk about it. And maybe there's no way of finding the solution straight away, but it's a way of getting closer to a solution where the different angles and the different needs are met.
Yeah, or maybe we're still at this phase where we're finding multiple problems and multiple solutions that actually all fit in a bigger wicked problem framework, and then we can just kind of tackle them from different perspectives and different points in time, space, etc.
On that note, we thought it could be interesting to showcase the Resource Watch webpage, which is a platform that we've been working on the past years, and it hosts over 300 datasets. Datasets coming mostly from data science or mostly from GIS are brought in together. And in this case, it's possible to explore by topics and to see at the same time on the same web map information coming from different sources. For example, in this case, we have the fires that come from NASA, and it's possible to check everything about their metadata, the methodology, which is super important to understand the assumptions that are behind. There's even a disclaimer of how things should be used, and even there's a possibility to have a little play with the data before maybe downloading it, if one thinks that this data is information. that is useful for further analysis. So as I mentioned, if we are interested in fires, we might want to check what other information might be that is related to this layer, and burn areas might be of interest. So the layer before was from NASA, now I'm adding a layer from the USGS, and it's possible to visualize everything on the same map, and eventually also download from source and understand in only one place all the elements of the data sets. And then this is again probably bringing up the GIS, the data science from different institutions, NASA, USGS, but there's, as I said, there's over 300 data sets and many other institutions that have included their information included in here. So I think it's a first nice place to go if we are more data science, to identify how many GIS data sets there might be there, but also if we are a GIS person and we are less comfortable on what's the data science behind, it's all curated by humans, as we like to say, and it's curated for humans.
I think one thing that it's also kind of a good reflection, or something that it's a bit more like down to earth, is that we also realize that we can't learn everything. Like, we cannot be the repository of all the knowledge to address a problem that's so complex as climate change, so big. And even just from a technical, really, like if we just boil it down to data science and GIS, if you are extremely knowledgeable of GIS and extremely knowledgeable of that data science, it's a lot. It's like, it's really, really a lot. So the likelihood of you being able to do both, and we're kind of young, we're kind of old, we're like in the middle. I don't think we had enough time to do all this. We would just have to simply focus on these two topics, and we would still be probably on the surface. So it's really good to have a team to rely on and to teach you things, or even just to save you the time of teaching some things because they're not useful anymore, or because they're going to be completely redundant in 6 months.
Anyway, that's a little bit like the summary of the internal discussion we had, which is mostly there's lots of skills out there, there's lots of knowledge, and to tackle a problem as complex and wicked as climate change is about having the input from everyone and try to build on top of each other's and how the little pieces work.
Yeah, we definitely need to work in the intersections.
And I think now there's a little bit of time to take some questions. So I guess we are somewhere to answer to them. So,
yeah, hopefully in real life, real time.
So thanks for listening.
Yeah, thank you for listening.
Ciao.
Bye.
Greta, thank you so much for joining us, and also to Luisa, who unfortunately couldn't make questions now, but who did join us for the presentation. Greta, just a question that we've heard many times throughout the conference is about how do you get started in spatial data science? So I wanted to ask you, how did you get started working in this industry, and specifically on spatial applied to climate change?
Well, so thank you for having us. Apologies from Luisa. And in my case, particularly, it was doing research on biogeography. And that's when I had to start fighting with projections and not understanding why things, when exported then and having opened again, they wouldn't match, and not understanding why my North American fishes were not placed in North America. So it was to understand the richness in that continent.
Mm-hmm. And so for people who are joining the conference and they're looking to learn more, are there any particular resources that you would recommend, or courses online, or things that you did to learn along the way?
I think what I would recommend is to have a project, something that actually it's important for you, and it might just be a bachelor's project, which is important because you want to get your bachelor, or it's something that you want to show on a map. And because it can be quite temperamental to fight with spatial data, I would say start with something that really matters to you, and along the way, asking questions using the resources from Stack Overflow. There's QGIS that is open source and can be downloaded. There's huge communities out there that I think are always very happy to help. So I think that would be my recommendation.
Awesome. Thank you very much, Greta. Well, there was some people who are big fans of Resource Watch on the chat. So if anybody wants to chat to Greta on the chat more about Resource Watch, please feel free. But as we're running 5 minutes behind, I think we're going to say, Greta, thank you so much for joining us, and hopefully see you at next year's edition as well.
Thank you for having us. And yeah, hopefully see you next year. Bye.